On September 5, 1977, humanity launched an ambitious spacecraft known as Voyager 1. At the time, the mission was not designed to last more than a handful of years. In fact, its original assignment was expected to run for only about 5 years, focusing primarily on flybys of Jupiter, Saturn, and their fascinating moons. Few, if any, of the scientists and engineers behind the project could have imagined that nearly half a century later, Voyager 1 would still be traveling, transmitting data, and rewriting everything we thought we knew about the cosmos. Fast forward more than 48 years, and this little spacecraft has accomplished what no other human-made object has ever done. It has ventured over 24.8 billion kilometers from the Sun, moving farther from its birthplace than anything else we have created. Its continuing mission has become one of the most extraordinary sagas of scientific exploration, carrying it beyond the protective boundaries of our solar system and into the uncharted depths of interstellar space. Voyager 1's role is no longer just that of a planetary probe. Instead, it has transformed into a cosmic pathfinder, venturing into regions where no spacecraft has gone before. With each transmission it sends back, it offers humanity rare insights into the true structure of the galaxy and the violent forces that shape it. And yet, in the process, Voyager has also stumbled upon phenomena so baffling that even the most established scientific theories are being forced into reconsideration. One of the most remarkable moments in Voyager 1's long life occurred in October 2022. Despite being more than 4 decades old and operating on dwindling power reserves, Voyager's instruments picked up something completely unexpected: a surge of gamma radiation so intense that astronomers would soon label it the brightest burst of all time. This wasn't just an ordinary cosmic event. The gamma radiation was so powerful that it had measurable effects on Earth itself, temporarily altering our planet's ionosphere and creating a ripple effect that scientists detected across multiple global observatories. To think that a spacecraft drifting billions of kilometers away could detect such a signal, and that this signal would in turn influence our own planet, is nothing short of extraordinary. What made the discovery even more astonishing was its origin. Unlike the rare and massive explosions such as hypernovae or neutron star collisions, phenomena usually associated with extreme gamma-ray bursts, this particular event appeared to come from what astronomers initially described as a seemingly ordinary supernova. Supernovae are not uncommon in the universe, but the sheer intensity, narrow focus, and peculiar behavior of this gamma-ray jet were unlike anything recorded before. Instead of being wide and diffuse, the jet of radiation accompanying the burst was tightly concentrated and exhibited strange anomalies across the entire electromagnetic spectrum. From unusually strong radio signals to puzzling X-ray fluctuations, the data hinted that this was not simply a stronger version of known phenomena, but potentially evidence of an entirely new astrophysical process. For many scientists, it was a discovery so profound that it forced a rethinking of supernova models and the mechanisms that drive them. Yet Voyager 1's revelations did not begin or end with gamma bursts. Long before this event, the spacecraft made another startling discovery: the presence of a mysterious magnetic wall at the edge of the solar system. This wall is essentially a boundary where the Sun's magnetic field interacts with interstellar space, creating a kind of fluctuating barrier that shields our system from incoming cosmic radiation. Voyager 1's data revealed that this boundary, also called the heliopause, was not smooth or uniform. Instead, the spacecraft detected sudden shifts in magnetic strength, turbulence, and irregular fluctuations. Years later, when Voyager 2 crossed the same region, its instruments reported a different experience: a thinner and more stable barrier. This led scientists to theorize that the heliosphere, the bubble-like magnetic shield surrounding the solar system, changes dramatically depending on the Sun's 11-year activity cycle. At times, it may strengthen into a formidable shield, while at other times it thins and becomes vulnerable. This has profound implications. If the heliosphere weakens significantly, then interstellar radiation and cosmic forces could penetrate much more deeply into our system, potentially influencing planets, including Earth, in ways we do not yet fully understand. Another unexpected revelation came when Voyager 1 officially crossed the heliopause. Instead of finding a sharp division between the solar system and interstellar space, the spacecraft discovered something stranger. The two regions seemed to blend together seamlessly. Voyager's instruments recorded that the interstellar magnetic field appeared to align unusually well with the Sun's magnetic field, a surprising result that challenged all prior expectations. Instead of an abrupt cutoff between solar influence and galactic influence, there seemed to be a smooth transition zone, as though the solar system is more entangled with the surrounding galaxy than previously imagined. This blending also came with pockets of varying plasma densities. Voyager detected patches of interstellar plasma that were unexpectedly turbulent, with densities shifting dramatically over short distances. Far from being a static emptiness, interstellar space turned out to be an active and dynamic medium, a place of constant motion, structured by ancient supernovae, stellar winds, and other violent galactic events. One of the most hauntingly beautiful discoveries Voyager has made is its detection of faint shock waves traveling through interstellar space. These waves are the echoes of supernova explosions that happened millions or even billions of years ago. Though long past, their energy still ripples through the galaxy, carried by high-energy particles and plasma. Voyager's instruments detected that these shock waves are far more concentrated and energetic than expected, hinting at their tremendous power and the role they play in shaping the galactic environment. By studying fluctuations in plasma density, scientists are able to trace back the fingerprints of ancient cataclysms, a reminder that the Milky Way is not a tranquil space, but a realm scarred by endless cycles of stellar death and rebirth. Among the most intriguing findings are Voyager's measurements of plasma oscillations, rippling waves traveling through the interstellar medium. These waves give scientists a way to measure plasma density far from the solar system, offering insights into the structure and behavior of the interstellar environment. The discovery of these oscillations shattered the old assumption that interstellar space was a static void. Instead, space is a dynamic ocean of interacting forces, constantly reshaped by stars, explosions, and cosmic radiation. The plasma waves may be remnants of ancient stellar events, but they may also be evidence of ongoing processes that we do not yet fully understand. Voyager 1 also detected unusual cosmic ray interactions. Instead of dispersing evenly through interstellar space, cosmic rays appear to concentrate in specific regions, forming puzzling patterns. This behavior defies existing models of how radiation should spread. The implications are profound. Either our understanding of cosmic rays is incomplete, or there are unknown forces or structures influencing their movement across the galaxy. These anomalies continue to spark debates among astrophysicists, as they might represent entirely new physics, or point toward hidden cosmic mechanisms that we have not yet identified. Perhaps the most perplexing of all Voyager 1's discoveries is the unexpected alignment between the interstellar magnetic field and the Sun's magnetic field. Scientists had long assumed that these fields would meet at odd angles, reflecting their independent origins. Instead, Voyager's data suggests a mysterious parallel alignment, raising questions about whether there exists a deeper connection between our solar system and the larger galaxy. Is this alignment a mere coincidence, or is it evidence of a galactic-scale structure binding stars and systems together in ways we never suspected? If true, it could mean that the Sun, and by extension Earth, is more interconnected with the galaxy's magnetic web than anyone realized. For nearly 5 decades, Voyager 1 has traveled relentlessly forward, becoming not just a spacecraft but a cosmic detective, a time capsule, and a symbol of human curiosity.